Continuity. Continuity is just checking to see if the function that you are looking at is a smooth, continuous function. Meaning, again, no breaks, no holes. What is the definition of continuity? Three things have to be true. Number one, f of a exists. Remember, this is all about language, right? This is my foreign language telling me that there's a value everywhere. Okay? Again, that means there is a value for any number that I put in. I never get undefined. I never get a hole that cancels out. There is a value no matter what. The second thing that has to be true is that there has to be a limit everywhere as well. Okay? So I have to have a limit everywhere. That means no matter what, I look on this graph, and at everywhere, any point I pick, to the left and to the right, it's going to the same place. No breaks. So this first one means no holes, no asymptotes. This is no breaks and no asymptotes. Nothing where it is separate. Then the last rule is that that value and that limit for any a I put in has to be the same. Everywhere. If I think about continuity, again, all I'm thinking about is a function that has no breaks, no holes, no asymptotes, no nothing that pulls the graph apart. Now, we focus on three types of discontinuities in pre-calc. In calculus, you add another one. But ours are infinite discontinuity. That just means an asymptote. So if it's got an asymptote in it, blown. There is no, it's not continuous, okay? A jump is what I call a break in the graph. And I'll draw a picture of all these so you have something to look at. And a removable is a hole in the graph. Now, some people get mixed up when it comes between the jump and the removable, and I want to just point that out, all right? So let's start with an asymptote. It looks like a graph. That has an imaginary line blocking part of the graph. We all know that. We've seen those before. If I see that in the graph, at whatever this location is, I'll call this A right here. At this location, it doesn't have a value, it doesn't have a limit, so there's no way they can both be equal. So it blows all three of those. Okay? Here's a break. Or a jump. And I have two types of breaks and jumps that I'm going to see. One where at the break I don't have a value at all. And one where at the break I do. I can even have a picture where it looks like this. here's my break, here's my other side of my break, and it doesn't matter what it looks like, and I have a value that falls in between. So, but a break is a very clear break. We call a jump is a physical break in the graph. It does not connect. A hole or removable actually just has a hole in the graph that it would be continuous if that hole weren't there. It comes together on both sides. So it has a limit at A, has a limit there, it just doesn't have a value there. Or I can have a hole in my graph, and again, it doesn't matter what it looks like, and I have a little value that's just not filling the hole. So it's got a value, it's got a limit, they're just not the same. Breaks have holes in them, but not like a removable function with a hole, okay? Where the removable function will come together on both sides. All right. So, is this graph number 1 continuous? No. Why not? There is a jump or a break. Not continuous. Continuous. There is a jump at x equals 0. How about the next graph? Is it continuous? Yes. It's a smooth graph. No breaks, no holes, no jumps, no asymptotes, nothing that would ruin its continuity. Continuous? No. It's got an infinite discontinuity at 2. All I have to do is kind of look and see. How about 4? Continuous. How about 5? No. There's a hole in the graph. We call that removable. What if on your test you call it a hole? Fine, I don't care. That doesn't bother me. That's what it is. The technical name is removable. So it's not continuous. It's got a removable discontinuity at x equals what? -3. Yep, I'm looking at the x value, not the y value. There are even occasions, spit it out, where you will have more than one. And so this one is not continuous. There is a removable discontinuity at x equals -4. And there is an infinite discontinuity at x equals 1. Sometimes they're even going to give you specific values that you need to look at. And it could be continuous at that value. Maybe it's not, but it's kind of the same thing. Is this function continuous at -4? Nope, there's an asymptote. Is it continuous at 1? Nope, there's a hole. How about this guy? Continuous at 3? Yeah. I don't see any issues, no holes, no breaks, no whatever. So you have on your test tomorrow